Okay, the third part of the chapter is investigation. There are three major investigations of this chapter, and they are usually asked in the paper as well, in a very critical thinking way, in the problem solving way. Okay, either there are the certain investigations which come in the P4 as well, and there are certain diagrammatic questions which come in the P1. And this oxen question, which we have discussed in the earlier video, is a part of P2 and the tropism. So investigation, let's go through the investigation. First investigation is about experiment to demonstrate positive phototropism in the shoot tip. Means we will need to study that whether the shoot tip shows you the phototropism or not. So this investigation is here to be demonstrated. So what we have done, we are studying the light, right? We are studying whether the tip of the shoot shows the positive phototropism or not. It means that I need to put the plant in light in order to see whether it shows the phototropism or not. Hmm? What will be the control? Control means the vice versa of your experiment. We are studying the effect of light on the phototropism on the shoot, right? We are studying that. So if I'm providing the light in the control setup, what I would do, I won't provide the light, or make the scenario in opposite way. If I'm putting the plant in a dark room, it means my other setup would be in a room where the light is provided, right? Okay. In order to study this phototropism, if I put the plant in a box where a certain area is open and the whole box is closed, and I make a certain area where the light is provided to the plant. You can see here in this picture, I have placed a plant in a room and I have opened a window in a certain direction to see whether the effect of light is positive phototropism or not. Because if the plant is bending towards the light, it means that yes, the light has an effect on the shoot growth, right? And if there's no effect of the light and the plant is growing in upward direction, regardless of the direction of the light, right? It means that there's no effect of the light on the shoot. So we can call it negative phototropism. So if we are studying the light, it means the light is an independent factor, and my plant is bending or changing the direction, or the direction of the plant is the dependent factor. Light means my light is controlling the movement of the plant. So light is the main factor here. Okay. And the changing of the plant position is the effect of it. Okay. So what you are studying actually the direction of the light. It's the main investigation of yours. So this is independent factor, and your dependent factor is how the plant is responding towards it. If there's a bend, if you see any change in the direction of the plant movement or plant growth, it means that yes, there is a effect of light. So that is the dependent factor. Okay. What will be the control you will make? You will, in the another setup, you will put the plant in a clear dark room. There's no source of light present to it. Yeah, okay. All right. Because if you're studying something for the light, it means that the vice versa thing you will make, that is the opposite of it, that is dark. Okay? So this is known as control. I'm talking with the in the respect of P4, right? In the P4, if there's any investigative question or if there's a design and experiment question, this is how you are going to make the control and variable setup. Okay. A darkening black box is taken having a small window on one side. So these are the apparatus here, a black box, and having and there's any slit in the box or a small window you have created. Okay. Now, what factors you have kept constant? A well-watered potted plant is placed inside the box, right? It means that both plant would have a same amount of water, both plant would be of same species or would be of same height, okay? So you can see the comparison. Comparison is only be seen when both things are same. Then you can see the comparison because uh, the factor which you are allowing to be worked on that setup is different, okay, but the object which you are working on needs to be same, so you can see the comparison. That's why we are keeping these things constant. There's a difference between control and a constant. Control is actually a scenario you have created against the experiment you are studying. And constant are the variables which you are providing to the plant regardless of the control and the experiment setup. Okay. So both plant will be well watered, same amount of plant water would be given to them, same species of the plant would be of the plant you will take, and the plant height would be same. So there will be easy comparison you can make. All factors were kept constant. For example, water, same species of the plant, same length, even the carbon dioxide or to both setups except for the light, because you're studying the light. This is the only factor which you will change. If the window is kept closed for 24 hours, the plant shows normal growth. Right? You know the oxygen works in a shaded area. So it doesn't mean the plant will not grow in the darkness. It will grow in the darkness. Okay? But there will be no that certain, but the growth will be slow. Okay? Plus there will be no bending of the plant because there is no source of light. So the plant direction will be in a straight upward. Okay. However, if the window is kept open, it is found after 2 days that the shoot tip bends and grows towards the light, proving that the positive phototropic mechanism has occurred here. See, the length of the plant has increased as well, plus it has bent towards the light. Hence, it has proven our statement that yes, the light has a effect on the shoot tip. Means the shoot tip does show the phototropism, positive phototropism. Okay, this is one investigation. Our second investigation is about to show experiment to demonstrate negative gravitropism in the aerial stem. First, we have studied the positive phototropism in the stem. Now we are studying the negative gravitropism in the stem. That why do you think the stem will grow towards the gravity, or it will grow towards the sun? Let's discuss that. We have taken an apparatus. You can see this apparatus. This is known as clinostat or clinostat. It's a rotating machine which cancels out the effect of light on a gravity. Like I have placed this pot of plant in a horizontal condition, right? In a horizontal way, and this is a clinostat, means it rotates. This root will keep on, this pot will keep on rotating. So if it will rotate, uh, uh, it means that if there is any sunlight falling over it, okay, this is, for example, this is a source of light we have provided. From upper part there is a light, and from downward there is a force of gravity. Okay. So if it keep on rotating, it means that all part of the plant or all part of the shoot is receiving the same amount of light, and all part of the roots are receiving same amount of gravity, right? Because it is keep on rotating. What if I stop it and allow the plant in the same position of a plant in horizontal way? What will happen then? What will be the direction of the shoot now? Will it grow straight? Will it go downward? Will it go upward? Right? This is actually the purpose of the experiment. So, experiment to demonstrate negative gravitropism in the aerial stem. The clinostat has a, now let's go through it. The clinostat has a rotating pot-like container mounted on an X rod. This is known as X-rod. This is a clinostat. It's a rotating machine. The potted plant is fixed horizontally on the clinostat and rotated slowly, which completely eliminates the gravity as all the sides of the plant are equally stimulated. They are receiving the equal force of the gravity from all sides, means that every side of the plant is equally activated. Okay. If the rotation of the clinostat is stopped, if the plant is receiving everything in equal direction, so usually the plant growth is in a straight direction. Okay, means the plant will grow in this way, because इधर से भी force आ रही है, इधर से भी force आ रही है. Each part of the plant is receiving the same force of a light or a gravity, right? So the plant will grow in a straight direction. What is a straight direction? Horizontally, what will be the straight direction? This way. If it was vertical, then the straight direction would be in this way. Okay, as it is placed horizontally, it will move towards the right side. Okay, that is the straight direction. You can see this area is particularly growing in a straight direction. However, this one is showing something different. Okay, and why is showing something different? Let's see what our investigation is telling us. If the rotation of the clinostat is stopped for considerable period of time, like 2 days, 3 days, stop, it's not rotating anymore. It means now the force of gravity is now directional. Only one part of the plant is receiving that force, or one part of the plant is receiving that light. Only this area. This area is not receiving the light or gravity. This area is the gravity is only applied on this area. It is not applied on the upper part. Now, what will happen? You know, the shoot grows towards the light. You see, the tip of the plant, this area, is now bending slightly. Okay, is now bending. Means it is proving that the stem respond only in the presence of light. It doesn't have any effect of the gravity over it. Okay, because if it would, there would be the effect of gravity over the stem, then the direction of this plant which has bent towards upward, it would be downward. But it didn't grew downward. It didn't grow downward. It has shown its growth upward direction. All right, towards the light, not towards the gravity. So if the rotation of the clinostat is stopped for a considerable period of time, when the tip of the stem is observed to curve and grow upward, this proves that the stem tip is negatively geotropic or negatively gravitropic. Geotropic and gravitropic is same word. However, in our 5090, we use gravitropic. Okay. I hope this experiment is clear to you, that if we use the clinostat, what will be the effect of these certain two factors, light and gravity, over the stem. Okay, let's move to our last investigation. To investigate the effect of light or gravity on the growth of a newly germinating or germinated seedling. Newly germinated seedling means the seed has been uh, sprouted. Okay, and what will be the effect of light or gravity over it? Let's discuss this. This is actually the setup of the plant, right? This is the petri dish. This is the petri dish, and I have kept the damp cotton wool. Why moist cotton wool? Because it will provide the water. These are the sprouting, or you can see these are the germinating seedlings. You can see they are uh, very early age, at a very early stage of the germination. The roots are not grown properly. The shoot are not grown properly. They are in a growing stage. They are growing right now. ठीक है, We have taken that, and we have taken three seeds. Why we have taken three seeds? Because it will be easier for us to get the accurate result. Whenever you need to get the accurate result, either take the large sample, like usually three or four, will be easier for you, so you can compare the reading, or you can repeat the experiment three times. It means if I would be studying on a one seed, means I have to repeat the experiment three times or four times in order to get the accurate result, because accurate result will make my result valid. It will give the validity to my accurate result, and accuracy will give the reliability to my result, and reliability will give the validity to my result. Okay. Now, rather than repeating it three times, I have taken the three seeds, which are of the same species, of course, and the seedlings would be having the same rate of growth as well. So when we are comparing the result, we can see the change. Okay. And then what we have taken a petri dish, and we have put the seeds. Okay, and it's placed over the cotton wool. Cotton wool is moist, so we can provide water to it. uh, if you see, there are terms known as the shoot. First of all, when the seed is germinating, the shoot part is known as plumule, and the root part is known as radicle. Okay. um, Now, put the seedling in different direction, where we have kept in a different direction, so we would know that in which direction the plant is growing. Like if the seed is in horizontal direction, if there's any change, we can see. If the seed is growing in a vertical direction, if there's change, we can see. Okay, and there are two setups. In one setup, we have kept the petri dish stationary, right? It's not moving. And in the other one, it is moving with the help of clinostat. And we are providing it the light. And of course, there is a force of gravity on the seedlings automatically. Okay. Uh, Now, let's see what will happen. Setup. Set up two petri dishes with three mustard seeds and allow them to germinate. Place one dish on a clinostat and other to support on its side. Record the direction of the growth of both shoot and root for each. Okay, this is the method. Add some damp cotton wool to two petri dishes. Means you have taken two petri dishes, right? You are studying the light and the gravity effect. Okay. So your experiment experimenting setup would be this stationary one, because plants are in a stationary condition. They are not rotating. This is my control, that if I keep the plant in a rotating form. So it means that if the effect of the light or gravity is equal on the shoot area and on the root area, what will happen to the growth of the shoot and the root? And if the plant is in a static position, right, in a stationary position, what will affect of the root? What will affect of the light or a gravity on the root and the shoot? Getting my point? So you are studying the effects of those two factors. Your setup A would be your experimenting one, and your setup B would be the control one. Okay. Okay. Place three bean seedlings in the cotton wool in each petri dish. A, a radicle facing down. Radicle means they are talking about roots. This term radicle or the plumule you will study in your grade 11, or in the chapter development of the organism, the part of the germination. Okay, so radicle means actually the root part. In the A, if you see in the A1, the direction of the root area is downward. In the B, the direction of the root is horizontal. And in the C, the direction of the root is upward. You have placed the three seeds in the different direction. So you can see if there's any change in the bending or the growth of the root. Uh, it would be obvious, right? In this static condition, if you see the B part, for example, the gravity, this is the force of the gravity is in this area. Automatically, this is a common sense, of course. So very logical that this root will slightly start to become bend towards the gravity. Okay, it will bend. All right. Okay, what about this one? It is actually in upward direction, but the gravity force is downward. This root will now bend in this way. Okay, and A is already going towards the gravity. You won't see any change in the root direction. Okay, actually the root direction will tell you what is the where is the gravity force of gravity is applying, and the shoe direction will tell you where the force of light is applying. Okay, if there's any bending, you will get to know that that is the particular area where the force is being applied. That's why we have taken the three seeds in a and placed it in a different direction. Okay. Okay, so B is horizontally and C is facing upward. Cover each dish with the lid. Attach one petri dish to support or to its on sides. Attach to second petri dish to a clinostat, as you can see in the diagram. Place both light-proof box so that the seedling are in complete darkness. So this is one of the factor which I have kept constant as well to provide no light towards it. Okay, leave for 2 days and then observe growth of the seedling. Now this is the result. See, this is the result. The A seedling is growing towards the gravity. There's no changing. There's no bending or no change of the root growth. It means that the force of the gravity was in this direction. The B has tilted towards downward. It means this is the area where the force of gravity has applied and made the root to grow downward. And you can see this the C1 has made a curve and is now growing downward. Okay. Okay, all radicals have grown, all radical means I'm talking about the roots. All roots have grown downward, that is positive gravitropism. And all plumules, you can see here, then you see the stem in A, there's no light present. Okay, so that's why there's not a particular direction of the shoot area or the plumule area uh, in the source of the light. In the darkness, the shoot will always grow in a straight up position. Okay, you need to remember, in the darkness, the plant will always grow straight up. There will be no bending. Only bending will occur if there is the direction of the light. Okay, if the sunlight is falling on the tip of the plant, it will grow upward. If there is no light present, it will grow upward. Why it is growing? Because the oxygen work in a shaded area. Yes, the growth won't be that stimulated as it is present in the sunlight, but there will still be the growth of the plant. You cannot say that the plant is not growing in the absence of the light. The plant will grow, but the growth rate will be very low. But in the presence of the light, the growth will be very high because the light is present. The activation of the oxygen will be much higher than in the darkness. Okay. So you can see the plume is going upward. In the B, it has bent towards upward. In the C, you can see it's making a curve towards upward. Okay. In the setup B, we were moving it or rotating it. So the effect of the light and the gravity was cancelling out for all the directions. So there was no change had been seen. All plumule have grown upward. It has shown us that it was negative gravitropism. Actually, we are studying the gravitropism. In the first experiment, we studied the phototropism. In the second one, we are studying now the gravitropism. Okay, in this one, what does it say? All radicals and plumules have continued to grow in whichever direction they were placed. The effect of the gravitropism was cancelled out by rotating the clinostat. Okay, so this is your result. Now, the thing which we have discussed are written in these 2 points. The experiment needs to be done in a light-proof box in order to cancel out the effect of light on the growth of the seedling. That's why we we would see the effect of the factor. We actually have kept one thing constant, means yes, we are studying the light and the gravity on the seedlings, but what we did here, that we allowed the to study the gravitropism, and by keeping the light away, so it will be easier for us to see that whether the seed has shown the negative gravitropism or the positive gravitropism. Okay, this is about the three important investigations which usually asked in the examination. Thank you.